All right, so here we go. So this is our nice Bruce Lee quote. We have a few more along the way. Just be ready for those. Now, this is the abstract that I wrote for this particular session. I put it here because I needed to remember what the heck I wrote a few months ago, and they said, Burr, put together an abstract. And it was kind of cool because there's some clever writing in here, I thought. I even gave it to my wife last night. I said, hey, I wrote up some funny stuff. Talks about big, vertically integrated, what we called monoliths back in the day. It was long and laborious. So we used to do things that are nice, traditional waterfall, where someone got requirements and they brought it to the engineers, and the engineers would say no, and they'd go back to the customer and say, well, we said no, and they'd say, well, you got to do it anyway. And, and 8 months later, we had Hello World. Life was good back then. Now things are all crazy. And so we should be thinking about that because we're going to be talking about how to make it a little bit crazier. We're going to actually move fast. But I mentioned Bruce Lee, and I told this story actually a couple years ago when I was at All Things Open. I said, I actually was a kid that grew up in Alabama, a little Asian kid growing up in Alabama in the 70s. I know it sounds weird, but it happened. And my father thought, well, he was going to take his little Asian son, and we were going to go to Bruce Lee movies as a kid. So I actually got to see Bruce Lee movies. You should not take your child to Bruce Lee movies, by the way. They're ultra-violent, for one thing. But I fell in love with Bruce Lee, and it was a childhood hero of mine. So that's why you have the theme. And the Enter the Dragon theme was actually part of the Istio presentation I used to do. So if you ever see my service mesh presentation, we had that theme. But today we're not going to talk about service mesh. There was a great presentation earlier in the day by Lynn Sun. If you saw her, she did a nice Istio presentation. There's also the Solo IO people right here on the corner. You can go hang out with them and talk service mesh all day. We're not going to even bother with that thing. We got way cooler things to talk about today. Now, a lot of the things I will touch on, demonstrations that you'll see, is open source and hands-on tutorials. You can go get access to those tutorials and try them for yourself, right? Either in my GitHub repo, or you'll see there's a bunch of Red Hat ones here. And again, remember the slide deck is at bit.ly/bcloudy, where you have access to all the links. There's also, you can watch it at your own pace. If you feel I'm moving too fast, because I do move really fast, we only have 45 minutes, there's like a 6-hour version of this presentation recorded, and you can hit the pause button. It's a beautiful thing. It's up the O'Reilly. It's with O'Reilly, and you can just, that's actually a link. You can get directly to it on the O'Reilly platform. Now let's talk about cloud for a second, right? We have Azure, Amazon, Google. We kind of know about those folks. We also have some private clouds. Anybody here have a private cloud? On-prem kind of data center kind of thing? All right, fantastic. Few of you there. Alibaba, if you run things over in Asia, the IBM cloud, Oracle cloud, there's just lots of clouds. Everyone's got one. That's awesome because it gives us more choice. So if we are software developers and we want to build cool applications and deploy them anywhere around the globe, we can now. And I find that to be absolutely fascinating and absolutely amazing. But it does mean the CNCF, the Cloud Native Computing Foundation, has kind of blown up over the last couple of years. I started with this Kubernetes adventure back in 2015. It was like Red Hat and Google, right? Red Hat did it all on-prem. Google kind of did it in this cloud thing, and that was it, right? So people were like, how do you say babies? No. Kubernetes. We spent all our time explaining how to pronounce the word to different people, and now everybody's doing it. As a matter of fact, this is an old version of the ecosystem slide. So this place has exploded with capability in the last few years, and we're going to talk about some of the ones that I'm interested in. But you can basically, at this point, take your entire career and be a Kubernetes person. Kubernetes systems administrator, Kubernetes-oriented developer, Kubernetes-based architect. We're going to talk about some of those things from an architecture standpoint. Okay? Now, I often use these kind of slides. I talk about our journey. I like to think that everybody's on a journey here, and you've hopefully learned some DevOps. And I don't mean you built a DevOps new silo in your organization. I know you did. Okay, so everyone does that. If you're a big corporation, you now took a bunch of people and you said, you're the DevOps people, and now they're the new silo. That was kind of the wrong idea, but we'll have to move on. We don't have time to talk about that one. Self-service and on-demand elastic infrastructure. I really want to be in a situation where I can actually say, I'd like some stuff to run now, please. And yeah, that's not quite in most big corporations either, but it should be. Okay, it should be. Maybe you want to have some automation. We're no longer feeding DVDs into DVD trays. Does anyone even know what a DVD is anymore? All right, fans. You remember the tray thing? We'd put it in and, it'd go back in there and stuff would run. Yeah, things have really changed. Now, some of you are thinking, is that like a thumb drive? No, almost, close enough. Okay. So, we now have automation for all that sort of stuff. We have this concept of CI/CD, and we're actually going to spend our time on that today. So more continuous integration, continuous delivery kind of things. Some advanced deployment techniques. That's where your blue, green, your canary, your A/B test, I want a dark smart dark launch kind of thing. Maybe that might be from your Istio world, but that comes in the Istio world, but we're not going to spend too much time on that. But then you too can be like Bruce Lee and actually make microservices. I like this concept so much, and if you saw my keynote a couple years ago, you would have saw this version of it. But I like it so much, if you saw the one before that, it looked like this. I had the superheroes, I had Wonder Woman kicking Superman's ass. It's pretty awesome there. And then you can actually see the superheroes here. That's kind of the Raleigh skyline. My wife designed that, so it actually is really nice. So I keep showing it because I like the design of it so much. But here's the part that's funny. I used to say our goal was to get to microservices. Well, now it's just been declared by Gartner to be moving out of the trough of disillusionment to the plateau of productivity. What this means is it's no longer cool to talk about. Yep. So at this point, everyone's doing it. Just everyone said they're doing it. Just agree you're doing it too. There's a lot of kind of ways to talk about, who's doing what, you know what I mean? But we're not teenagers anymore. So, everyone's doing microservices, but we're not talking about it anymore. It's just kind of a thing. So that's cool, all right? But look at what's on the left side of my chart there, that little thing called platform engineering. Oh boy, now I got to put this thing down and use two hands. All right, there we go. So look over here, and you can see that there it says platform engineering. So that's the one coming up the left side of the hype curve. That's the one we're all going to be excited about a year from now. Just be aware of that one. As a matter of fact, this year it has its own conference, and it just started, so it's going to be the big thing. Just be aware of that one. This is my original version of the journey slide. So because microservices is no longer cool, no longer the destination, I had to put platform engineering there. All right, so we all are going to be platform engineers. We're going to use this thing called Backstage. Anyone heard of Backstage yet? Okay, well, you will soon, right? It's going to be like everyone's doing it. Everyone's got to have some Backstage. It's actually a nice open source project released by the Spotify team, also part of the CNCF, Cloud Native Computing Foundation, and the Kubernetes ecosystem. It's a developer portal. It's very clever. So you can basically make your own little developer portal with all your widgets and gadgets and all your little things developers should do and see, and have like documentation links and who is on what team, profiles. You can also have like what's called a golden path template, and people can actually start new projects doing things the right way for Kubernetes with CI/CD built in, and all kinds of awesome stuff in the Backstage world. But that's going to be the new hotness for the next couple of years. Just be aware of that one. And so adapt what is useful and reject what is useless, because we're going to talk about a lot of crazy things in this presentation. All right, so let's talk about Kubernetes for a second. Not long, because everyone here has already heard about it, but I just wanted to give you a little bit of introduction to it, because there are some nuances that you might not have seen or heard yet, and I'm going to show you something, and if it works, it's going to be awesome. But maybe a little something you haven't seen about Kubernetes yet. So one thing, we have the concept of maybe a developer or an application architect, the platform engineer. We have our ops people, and they're going to use a CLI or an API or some sort of interaction, a GUI with that set of masters, right? The control plane, we refer to this now. So you're going to have essentially an API endpoint there that they interact with. So a RESTful endpoint that you can interact with. And then there's etcd. And so what you do is, as a user, you basically say, here's my chunk of YAML, and you throw YAML at it. All right, that's the easy way to think of it. YAML stands for yet another markup language. You throw your YAML at it and magic happens. We're going to see some of that magic. And it's going to feel like magic, okay? Because it is kind of magical. But the real thing to understand is when you throw your YAML at it, it's going to go through a reconciliation loop. It's going to take a moment. It's going to think about what you said. It's going to take your declaration of desires and then make it happen. So as long as you have that little asynchronous aspect in your mind, you actually can start getting used to this thing. So it's not like when you run a bash shell script and things immediately happen. In this case, things eventually happen. And it normally happens within a few seconds. It depends on your latency. It depends on how far across the globe you're going. And we're going to see that today. But the scheduler and the controllers are a key part of that control plane. They basically say, oh, you threw some YAML at us. We put that YAML in the etcd database. We're going to look at it and go make it real in the world. So if you have that basic idea in your mind, now what can I do with my compute, storage, and networking? Because that's really what we're talking about here. I can basically ask for a bunch of compute, meaning I want 3 cores, 4 cores, 16 cores. I want 2 gigs of RAM, 18 gigs of RAM. I want to run this application from this base container image, or that application, or that application, or this thing. I want to run Postgres. I want to run my Java app, my Node.js app. I want to run stuff. This gives you self-service, right, as a solution. So now when I talked about self-service elastic infrastructure, Kubernetes is essentially that. I can deploy whatever the heck I want. That's what makes it so powerful. So we're going to get into that in a second. But in the control plane case, right, that's the API endpoint you're interacting with. And then you're going to have worker nodes, right? These are the people that are going to run your thing. I want to run this Tomcat. I want to run this Postgres. I want to run this Node.js application. I'd like to run 2 of those Java applications. So I have a little HA, right, high availability, a little failover, a little load balancing. You get all that for free. So if you only know one thing about Kubernetes, it's simply this. You get load balancing for free. You get rolling updates for free. Now, there is a little nuance to that. You have to know what the liveness probe and readiness probe do. But otherwise, the whole magic trick here is a rolling update. Now, for those folks who've been around IT for a little bit longer, you're thinking, well, I could do that before. Yes, you could. But you had to have a really big machine. And you probably spent a minimum of $100,000 to do a rolling update of Hello World. This case, you get it for free, okay? So that's what the game changer was when Kubernetes was originally born. All a Kubernetes person like myself had to show you was, watch, I can make an update. And you'd see it go dook, 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 up all of them, all done. We're going to see that in a little bit. But that concept is the claim to fame here. It's all declarative. It's based on an API. It happens asynchronously. And you get rolling updates for free. It's like magic. It's the most amazing infrastructure you've ever tried to play with. Now, we have gotten a little bit crazier in the last couple years. We've also said, you know what, those control planes, right, those three master nodes with their etcds, and that's why the magic number is 3, by the way. Etcd likes 3. I can put them out as pods in another cluster. In other words, I can have a hub cluster full of those master nodes running as pods, meaning I can actually load my control planes into a control plane of control planes. Sounds like Inception? Well, it kind of is. Okay, so, but this is kind of the new thing that people are going to be talking more about. It's actually how things like IKS, IBM Kubernetes Service, or GKE, you know, Google Kubernetes Engine, that's how they're architected. So, and actually what I'll show you is one of those clusters. You can kind of see there are no master nodes, there are only worker nodes. Where did the masters go? They went into some other little control plane house to keep them. Now, there are some key elements to understand here. The pod. The pod, of course, can be one or more container. You will see that when you get into Istio and Knative. You'll see it with Tecton also. I'll show you where it kind of visualizes, where it shows up. By default, you can kind of think of, okay, one pod, one container. That's the norm. But when you start doing these really advanced things with sidecars and init containers and things like that, you will see that there can be multiple containers in a pod. Now, the key question I always get when someone hears that, oh, I can put more than one container pod. I'll put my Postgres in with my Node.js. I'll put in my whole, LAMP stack. No, okay? Keep your databases out of your code. Keep your code out of your databases. Keep them separated, please, because that will cause you nothing but pain and suffering. Keep like items together and dislike items apart, okay? So even though you can do that, don't do that. It has one shared IP, one set of shared storage, which is ephemeral, and of course it has shared resources, shared lifecycle. You don't want to reboot your database every time your Java code borks and has to be fixed, because it will, right? All of us have that nice Java code we've had with WebSphere, WebLogic, JBoss. I'm an old school JBoss guy. And you have that old code that basically has the, connection pool problem. You know what I mean? You forgot to put the finally block on the try catch, and now every time something blows up, you eat connections from the pool, and the operations people have to reboot that Java app at least once a day, right? That's their job, so don't take their job away from them. No, I'm kidding. One nice thing about Kubernetes, it has an automatic reboot for those bad connection pool code you always wrote. And you're probably thinking, that's awesome. I actually had engineering managers come to me and say, really? You got automatic reboots? That's amazing, because my coders are horrible. They can't ever figure out how to put the connections back in the damn connection pool. This will save me a ton of time for rebooting Java apps. I'm like, there you go. It's worth the price of admission just to have heard that. Now, we got the replica set and we got the deployment. This is a kind of a declarative construct that basically says, I'd like a bunch of these things running. I mentioned earlier, you can be highly available, right? I might want 2 or 3 or 4 running simultaneously. What image is it based on? What is the liveness probe and readiness probe? We won't have a lot of time for that. But in other words, how do I know if it's healthy? How often should I ask it if it's healthy? Should I send traffic to it or not? Right? That rolling update requires a health check and requires some form of understanding if it should be part of the load balancer. That's the service, by the way. That's the load balancer that's basically giving that magic of rolling updates. And this is the magic trick of Kubernetes. The networking aspect, the service, is separated from the application component. And we're going to actually show you that in a second. Okay? So just keep that in mind. The network is separate from the app. That's incredibly powerful. That means you can do a lot of really dynamic things. You also have separated storage from the application as well. So if you do want more non-ephemeral storage, persistent storage, you have this concept of the persistent volume. And all this magic happens through labels. You simply have name value pairs, you tag things, and all the magic happens. We'll show you some of that. Okay, so let's get into this thing. I call this demonstration service magic. It is one of our tutorials, so you can have access to it. As a matter of fact, let's do this. Let's do this. I'm going to put on the glasses too, so make sure I do it right. But here it is. This is, again, one of our tutorials. I'm going to actually just copy and paste from it to make it easy. So let me get down over here to a nice Kubernetes. By the way, this is my Bangalore, New York, Toronto. What else do I have here? I've got a bunch of stuff running. We're going to come over here, though. Yeah, right here. That's my Wi-Fi connection. All right. Had to move it a few more centimeters. There we go. All right, so I'm going to create a namespace right here. And yeah, let's go over here. Let's do this. Let's copy and paste that. So we now have a new namespace. Get namespace. All right, and so we should have one in here called fun stuff. And what I want to do is create 3 pods. Okay, let's create 3 pods, and I'm going to actually use the deployment. Notice these are all declarations. So it's kind deployment. I want one of these things. I'm going to make it a Python thing, but these are just strings. These are just labels. The real element here is the image. So someone actually went out there and did a Docker build, Docker push. It lives out on Quay.io, Docker.io. Can live wherever you put your images. And by the way, it has a container port of 8,000. The programmer told me it exposes 8,000, so I know about that now. And I can come over here now and say, I want this Python application. So I'm just going to come over here and paste it in. So again, it's all by declaration. And you can see right there, the Python application is coming up. You can see it downloaded the image into my cluster, got it up and running. See the 1 of 1 there? That's 1 container, 1 pod. You watch for that number to change later as we get to the more advanced examples. So let's get a Go application in here, put that in, and let's also get a Node.js application in here. I purposely picked 3 different languages because the language implementation does not matter. The only thing that really matters is the endpoints associated with that code base. It all lives on 8,000, and it has the same URLs basically built into that code base. We're not going to spend a lot of time worrying about the code base because I just want to show you the magic of declarative Kubernetes. I now have 3 pods up and running. As a matter of fact, I have 3 deployments also. So the deployment basically creates a replica set. The replica set creates pods. And now watch this magic. I want a service as well. I mentioned service earlier. Service is my load balancer. I can say kubectl get service. All right, there it is. Let's see. Let's also watch it. And the reason I'm watching it is I'm waiting for that IP address to populate. So we're going to come back to that in a second. But let's also describe it. And I'm going to go to another port there. So I can describe it now. So notice I'm using this command called kubectl. Kubectl get this, kubectl apply that, kubectl describe this. So that's the normal pattern, right? Kubectl is how you interact with these things. And you can see there's the load balancer ingress right there. You can also see it right here. So now I have an IP address. Anybody with access to the IP address can actually get to my little application. You can too. Okay? So if I want to come over here and say, hey, let's try it. Let's curl, right? Curl it. Nothing seems to be happening. And there's a reason for that. Let's come back to that in a second. Let's get the IP address and the port. Dun, dun, dun. Let's go here. Curl IP port. Same idea. Yep. So it's not responding. So it seems like my stuff is broken, but it's not quite broken yet. And here's why. kubectl get endpoints has none. See the big none there? Because one of the key tricks to understanding the service to pod relationship is the labels. What are the labels associated with those pods? If I come over here and say show labels, you can see there are labels there. It says app my go and a pod template. But the key element to understand is if I say kubectl, kubectl, describe service, and I come in here and see where it says, where'd it go? We got to find it. Selector, see where it says in service my pods? It's looking for pods that say in service my pods. That's it. Key value pair, all the magic of the load balancer right there. So if we want to make that trick work, okay, let's do this now. Let's put our loop in place. Get that ready. And we'll watch the endpoints there. Let's kill that one. You notice I use a lot of different windows because I like being able to bounce around. But let's go ahead and label some pods now. All right, we're going to label the Python pod. And so if we do it right, notice did you see the label show up here in service my pods? There's now an endpoint that populated for the service. And let's see if we can get it to talk to us. And there we go. We're now curling it, talking to the Python pod. And if you actually were hitting that original external endpoint, get service, right? The IP address, you would see that also. So that is the nature of dynamic declarative nature of Kubernetes. If I want to come in here and add the others, let's say I want to add, we got the Python. Let's go ahead and get the node. And let's go ahead and get the Go. And it's just changing the labels. You should see those labels show up there. Look at our endpoints get expanded here. And you see it load balancing across Go, Python, and we should see Node. There's Node.js also. So that concept that's it, right? In my mind, that's all the reasons you want Kubernetes right there by itself. So if you had not seen that before when you heard about Kubernetes, then I think whoever taught you Kubernetes probably did you a disservice, because this is the magic. This is worth the price of admission. This is why you spent $0 to come to this session, because you want to learn about Kubernetes from that perspective. And I like that a lot. I like it so much that I've used it for a lot of different presentations. But for now, let's go ahead and just wipe out Python here. So we're going to take Python away. Notice the label went away for Python, which is this row. My endpoint, we lost an endpoint, and now we're just node go, right? If I want to take out something else, I can just remove the label. My Go, let's get Go out of the game. You'll see the endpoints change. Now we're down to one endpoint, and we're only looking at load balancing across Node.js at this point. Now, the awesome thing is, anything you can stick in a Linux container, which is almost anything, will work this way. You do have to keep in mind, though, that certain things want to be be longer lived, if you know what I mean by that. Like your database engines don't want to be trashed about too much, right? That's not something you might do with a database engine, but for any kind of application, Node.js, Python, Java, you can go crazy with it. They should be built to handle this kind of stress, okay? And this level of dynamic capability makes it really fun to do some really fun things. Now, let's talk about one more little bit. And I can see, by the way, multiple people have joined the slide deck right there. That's the bit.ly B Cloudy. Fantastic. Now, that was the intro to Kubernetes in a few moments. We got to move faster, by the way. We're moving too slow. We got to talk about CRDs. Because once you understand the basics of Kubernetes, we showed you can deploy any container image, and it just deploys, and you got load balancers, and you got all that magic stuff for free. But now, we can extend Kubernetes in all kinds of super clever ways with this concept of the custom resource definition. And I can basically create a beer, a pizza, or even a Kafka if I want to. So as long as you have the CRD in place, you can kind of go crazy with that. So there's some key commands you should just be aware of. kubectl version, kubectl API resources, kubectl get CRDs, and of course kubectl cluster info. That tells you who you're talking to and what it can do. So I got connected to this Kubernetes over here. I can ask it, what you got going on, Mr. Kubernetes? And they're going to say, well, here's what I can do. So I can connect to this one, get CRDs here. And by the way, the reason I use all these different windows is because I have them connected to different Kubernetes clusters, right? And so you can, by the way, that's only just a matter of playing with this kubeconfig. And it's just one environment variable. And now every window can point to whatever cluster I want any way I want. But you can see there's my custom resource definitions in this cluster. It's got all kinds of neat stuff. It's got Kafkas. It's got pipelines. It's got, what else we got? We got some applications in here. There's a lot of neat things in there, as an example. But if I go over to this other cluster, right, you can see there I said kubectl get nodes. Notice there's just the 3 worker nodes there. Kubectl get CRDs here. And there's a lot less. A lot less. So you can extend your cluster any way you like with all these new object types. And here's the most awesome part. You can create your own object types. Create your own custom resource definitions and custom resources and do with them as you will. And then when those users basically throw things at you, you then have to have an appropriate controller that looks for that object type, watches for that object type, and responds. So the nice thing is we've done a lot of that for you for free at Red Hat. We've kind of given you a bunch of things already. And one of those is like a pipeline, but also this concept of a Kafka. So let's see if we get a Kafka going here. Okay, so let's go kubectl, delete namespace. That was the fun stuff. Again, everything is declarative. I can just wipe out fun stuff, which had the Go and the Node and the Python, and get rid of those guys. As a matter of fact, we're not going to wait for it. You should wait for it, but I'm not going to wait for it. OC, let's build a new project here. Let's call this one Gordon. There we go. That's not how you spell Gordon, is it? So, okay. So right now we're going to be in the Gordon namespace, and I would like some things there. By the way, a namespace is nothing more than a folder where you put stuff. All right, it's just a logical way to group some things. And then I want to basically say I want some stuff there. Let me come get a Kafka object. Here's my Kafka declaration, and we're going to push that in, and we can look at it real quick while magic is happening. So it says kind Kafka. It says my cluster. It has replicas 3. I want 3 Kafka brokers. I want 3 zookeepers. I'm making it ephemeral, but it could have persistent storage also. You can see how the logging is set up here. What we need TLS. We want to listen on port 9092. That's standard Kafka setup if you do Kafka. And you can see just my little declaration there now has 3 zookeepers spinning up and coming online. If we wait just a moment longer, you'll see 3 Kafka brokers coming online. There they come, right there. So entire 6 nodes of a Kafka cluster coming through a single declaration of YAML. Now, I don't know if you've ever installed a Kafka for a production environment. It's not easy. But here, it's just a declaration. You can point and click it. You can throw some YAML at it. You can write a bash shell script. You can put it in a Git repo and have the Git repo make that declaration on your behalf. All this magic happens because we have this concept of custom resource definitions. We can override the service. That's why the Istio and Knative thing works so well. You can override service, and you can then have Git ops, right? You can have a Git declaration that basically sprinkles these things around all your clusters. And that concept is very, very powerful. So if I say kubectl get CRDs, I can say grep Kafka. We have Kafka objects on board. So if I say kubectl get Kafkas, there we go. You can see it says my cluster. I want 3 of those replicas. That's why you see 3 and 3. 3 zookeepers, 3 Kafkas, and it's ready. See, it says true ready. It's ready to rock. I have a fully installed production ready Kafka if I want it. And if I don't want it anymore, delete Kafka. Let's get rid of it. All right, my cluster. And I can just make it go away. See, it's all terminating now, and of course, it'll just eliminate all those resources, and all the cores and memory associated with it get cleaned up. So this concept of declaration is insanely powerful, and it's kind of what we do in the world of Kubernetes here at Red Hat. We have this concept. Where to go? Okay, and we're going to play this game here in a second. But if I come over here, you can see I can say I have a bunch of operators, installed operators, and one of them is known as AMQ streams, which gives us the Kafka objects as an example. I also have applications. I also have this runtime fabric, and I have pipelines here also. And the pipelines gives us pipelines, right? When you hear the word pipeline, hopefully that means something to you. We're going to show you that in a little bit. But that's the CI side of the CI. Yes? Yeah. Which game?
We actually have a gamification component, so if you attend a featured session, you can be awarded points.
Oh.
Accumulate points, which have to have code in order to put it in the mobile app in order to be awarded.
10-10.
10-10, 10-10.
I didn't know there was another game. You guys are going to get to play my game too. Oh wow, there's 2 games here. Everybody, hopefully your battery is ready to rock. All right, a couple more slides here. So what you just saw was this thing called stremz. It's an operator out in Operator Hub. You can just go to stremz.io and install it in your Kubernetes cluster, and now you have Kafka magic superpowers for your Kubernetes. Okay, so that's what that guy is. We just did that demo. There's recordings, by the way. But now I want you to play my game. This is not a 10-10. On your phone, you can zap that barcode there, and you'll open up this game. I'm going to go ahead and open mine up. And yeah, all right. Looks like it's ready. It's going to say waiting game. But yeah, just pull open that barcode, or you can go to bit.ly raceburr404, and it'll bring it up in your mobile Safari or mobile Chrome or whatever you have there. Not tested in all the mobile browsers. I've not even tested it that well, so who knows? It may work or may not work today. But so there you go. You guys have it open? I can actually kind of tell how many people have it open. So let's go look real quick. Let's go look. Let's see here. I'm going to go to my main dashboard here and here. Oh, we do have people connected. So let me refresh, make sure we're all connected here. And you notice we go ahead and assign you a name and a team. So there might be Hoyland here, or Kunin, or Ramsar. We make up the names, by the way. We have learned over the years, if we let people enter their own name, bad things show up. For some reason, programmers are just naughty. So we kind of make up names for you now. And you're probably thinking, my name's cool. I wouldn't be naughty. Yeah, but the rest of you, we know you're naughty. Okay, so you're on a team. And what's going to happen, all you got to do is provide energy to the windmill that you'll see in a second, and that's going to make your team's car go around the track, and there's also a leaderboard we'll see out the top 10 finishers. So let's go ahead and get that started, this little game right here. So we're going to hit the button, and we're going to go. And now if you notice on your phone, there's a little windmill. Touch that, and you're going to basically make it move around. Let me see. I'm going to come over here to this one. Oh, the yellow team's falling behind. I got to help them. Come on. You guys on the gray team are really fast. Let's see. I think we're going to beat us. Come on, yellow people. You're not trying hard enough here. All right, there it goes. Okay. Boom. They're going to beat us to the finish line. Oh, look at it. Look at all those real-time updates. So we're still not quite finished yet. Almost. Oh, made it. And you can see there, we have Soderman. Who's our Soderman? Should be someone here in the room, Soderman? Yeah, way in the back? All right. You were on it. And Voigt, where's our Voigt? It's like the back of the room was on it. They couldn't even see the barcode. What's wrong with you people in the front? Okay. All right. So now that's just a game. But here's the part that's interesting about this game. Okay? It is all running back here on a Kubernetes cluster I configured. It's using the Kafka that you saw earlier, except not the same one, but the same exact idea. Give me a Kafka. It also has an InfiniSpan data grid. That's how you get the real-time updates to that leaderboard. And there's the application. You can see the application has, 5 pods associated with it to give it a little redundancy, a little failover, a little high availability. But you just basically say, I want these things. You just declare these desires, and magic happens. So an application can be actually very advanced, and it's just running here on Kubernetes, okay? So let's actually make a change to the application. We're going to come back and explain this in a second. So let me go over here. Where is that guy at? Is that over here? Okay, yeah. All right, I actually have an endpoint that I'm also polling on it. Notice it says it was updated at November the 2nd at this time frame. By the way, it's actually rotating across all 5 of those pods. That's why the timestamp is slightly different one from another. And I even get a timeout based on my network connection. But you can see it's basically now 5:21. It's UTC time, right? So I didn't set it to the right time zone. It also depends on where I put my clusters. I forget where I stuck this one. But let's actually change the code. Let's make a code change. So as a developer, I might want to make it say namaste. How about that? All right. And I want to change it also so it has a new feature for you. So we can enable shaking. So you'll be able to shake your phone to give it the energy. Shaking actually does provide more energy. We're not going to turn on blowing because we're having a global pandemic. All right, so we're going to leave that one off. But now you can go in there and basically say, I would like to enable shaking. We're just making code changes. And this one right here is that little message you see over here. So let me do a git status. Yeah, I made 2 changes to 2 files. I'm going to git commit. All right, okay, we made it namaste, and we made it true. And we're going to git push. Now, that's going to go back out to GitHub. And that GitHub is going to then basically configure a webhook or trigger a webhook. That's going to cause a pipeline to execute. Again, we have pipeline objects in this world too. And if we look at the logs for it, we will see it do the normal things a pipeline would do. It's going to do a git clone. It's going to actually do a Maven build. It's a Java application. And that Maven build, of course, will download the internet. And that we do cache the artifacts from the internet. But it's going to do what you do when you build an application, right? And so we're not going to wait for it. We'll come back to that in a second. But it will go through the rolling update and roll it out to all you folks in a few minutes. It takes about 3 minutes or so to execute. This also leverages something called Argo CD, and we're going to come back and talk about that more in a second. All right, so lots of fun stuff there. And whoa, we're going to run out of time, aren't we? Let's see. 45 minutes goes by really fast, and as I talk so slow, it's a problem. Okay, so you can see this is the architecture of what you just saw. You basically have it on your mobile phone. It makes an endpoint call, REST call, real simple to those application pods. The application pods, of course, have access to InfiniSpan and Kafka. And InfiniSpan is just an in-memory data grid like if you would use Redis or something else. And then, of course, it updates my little dashboard, and you saw all the data come streaming in. The reason we use Kafka is because you guys were pounding the heck out of those phones. So think about the number of transactions you just created in a few short minutes. Thousands and thousands of transactions. So you want something like a Kafka which can handle that load, right? You can do it with other things. ActiveMQ, I think, would have been fine also. But, you know, a streaming engine is kind of interesting. Plus, if you want the real-time feedback for your users, a streaming engine married with something like a data grid and memory data grid is very powerful. So we'll come back to that. But a lot of this magic, by the way, can be seen at Operator Hub IO. Go download these things for your Kubernetes engine. So I want the Strimzi Kafka as an example. Maybe I want MongoDBs. I know the folks from Percona here. Is Peter here in the room? No? He was here yesterday from Percona talking about how to do MySQL and Postgres. There's also Crunchy. They have a booth down over here. So lots of awesome stuff that you can basically load right into your Kubernetes cluster. All right, let's keep going. You must be shapeless, formless like water. I love that one. All right, okay. So let's talk about Tekton. We're going to talk about Argo, and we're going to get back to our demo and see if it's actually running. So Tekton, much like Kafka, is something you declare and you use inside your cluster. So I know everyone here has Jenkins. How many people have Jenkins? Yeah, see, we all love Jenkins, right? No one loves Jenkins. That's okay. But, you know, it's our legacy system. We've had it forever. That's okay. But what this is instead of having that Jenkins, whatever they call it now, control plane, I think everyone's using the word control plane, what we used to call the master, right? That thing was responsible for orchestrating all these workers or agents or whatever we call those things now. Well, guess what? That looks a lot like Kubernetes itself. That's what it does, right? It has this control plane that manages all these workers out there and basically distributes work across them. Well, why not use Kubernetes for the same thing? And that's what Tekton does. It says, declare me a pipeline, declare the tasks associated with the pipeline, and then you can basically use Kubernetes as a big old CI engine that's insanely scalable. So that's what Tekton has done. You have a pipeline definition, a task definition, a step definition, and it simply just matches containers running in a pod. So let's see if we can see that real quick. I'm going to go back over here to my command line, and let's do, so you can see it still says hello, so that update has not taken effect. kubectl get pods. I'm in the wrong namespace. Let's go to the right one. There we go. Okay, you can see there's my pipelines. We're going to talk about those more in a second. But there's the pods I was talking about, which represent the application. There's the Kafka and the Zookeepers. There's the InfiniSpan. That is my webhook endpoint, by the way. That's why that guy's there. So that's for webhooks. But what we need is to go look at the, let me see. We want to look at the pods. Well, let's just look at these right here. You see how it says 0 of 1, 0 of 3, 0 of 2? That's because those are the tasks in the pipeline. Git clone, Maven build, update the Quay.io image repository, and then do another Git update. So we'll look at those in a second. But those actually configure how a pipeline executes. It's 0 to 3 because 3 different containers execute in that pod, and they're completed now. They've finished. So it's no longer a live running thing. It is now terminated because it did its job. So Kubernetes can make things run forever, like a daemon, or just run and be done. So it offers that cron style way of doing things or batch style way of doing things also. And that's exactly what Tekton takes advantage of. So if I say kubectl get pipelines, right here, whoa, it helps if you spell pipelines correctly. You'll see I have a pipeline called the wind turbine pipeline. I can do all my standard verbs against it. Let's describe the pipeline, right? The wind turbine pipeline. I should have made that word shorter, but you can kind of see how it sets up. If you look at it, it kind of reads top to bottom, pretty straightforward. Let's actually get up here near the top. So it's going to do a git clone. You got to give it the URL where to get it from. You want the master branch or the main branch. I might want a certain subpath. Let's see here. I want it to be verbose. I want it to, I want to know where the user home is. I want to, so we're going to do a git clone. And after our git clone, we're going to do our Maven. We're going to run our Maven command. Okay, you can see it run there. After the Maven command, it runs this thing called builda. And by the way, you can see the rolling update happening now. So it's rolling out to my production clusters. Okay? But that concept is very, very powerful, and it's all done in a declarative way. All right, so we got just a few minutes left. I want to get back to that demo, but I want to show you one other thing, and that is Argo CD. And that is because with Argo, it is the other half of the equation. With Tekton, it works really well all within the context of a cluster. It's a big workflow engine. But now I want to distribute my app across all those clusters I talked about earlier. So let me just show you Argo CD in action just for a moment. Notice over here I have 3 different clusters running my same application, but let me make a code change to those applications. And all I'm actually going to do is update the configuration. For Amsterdam, I want to say hello. And for Bengaluru, I'm going to say namaste. There we go. And then over here, we're going to also have New York. So I like to make fun of New Yorkers. So let's say, hey, y'all. That's what they say in New York, right? Yeah. Okay. So I think I made the right changes there. Let's see. Git status, git commit. Let's go ahead and say we now have localized our messages. Git push. And I'm going to make this go quickly so we don't have to wait for it. By default, Argo CD syncs against the Git repo every 3 minutes. Let's go ahead and say, nope, sync a little faster than that. And if we come back and watch it, you'll notice my pods out here will receive the rolling update. But in this case, it literally is going out from New York to Amsterdam to Bangalore. So I can do a distributed deployment from a central location anywhere around the globe as long as they have access to the same Git repo. So Argo CD is another one of those things that's insanely powerful. So with Tekton and Argo, that's what makes the magic happen for this mobile game. So if we come back to our little mobile game right here, let's see if we did roll it out. We don't need the calendar. So refresh your browsers, please. And we will see if we made that change out in the world. I'm going to go back over here. Let me hit refresh over here. Oh, the QR code. Okay, hold on. Yeah, all right. And where was the QR code? It was right over here. Doop, right there. But you should see it says enable shaking on your phone now. And I'm going to refresh mine. There we go. You got a little red banner. And that's because you do have to tap that. You do have to say, yes, I will enable it. On an iPhone, it says, are you sure you're sure? Yes, I'm sure. And then you say, it says waiting for game. And we hit start. And we can shake. Shake. Whoop, come on. My dashboard disconnected. Come on. I think my dashboard is disconnected from my network, but the game is working. So part of the problem might be because I'm using this phone as my network. Let's see. You guys make it happen? Oh, man. Oh, boy. So how will we know when we're finished? I don't know. Maybe never. And I did log back into it. Yeah, it says 25. It's got about 25 and 26 people connected to it, but my updates have failed. I'll have to go fix that. Okay. All right, you guys keep doing that for next hour. We'll be good. Okay. Well, we do have to wrap up. We're a little bit over time. Other things that are interesting, there's a new open source project that Red Hat has released called StackRox. You basically can put in-cluster image scanning as well as network policy scanning. You know, you can also do things like put in your pipeline a nice CVE locator. Very powerful stuff there. Something called Skupper allows you to bridge, basically network from cluster to cluster. Lots of free books. I'd encourage you to check them out. And you can also get access to that recording I mentioned earlier. And my last quote from Bruce Lee is, "Be happy but never satisfied." I love that one. So thank you so much.